Hello everyone. The title of my lecture is Maximum Power Transfer Efficiency of MIMO-WPT System. It also can be called as MIMO. It can be applied to near-field coupling to far-field coupling seamlessly. My name is Qiaowei YUAN from Tohoku Institute of Technology of Japan. Please enjoy my lecture today. Let me introduce myself briefly. I'm professor and also the head of IoT Research Center of Tohoku Institute of Technology. I also served as an appointed professor of Tohoku University of Japan. Now here is the volunteer activities for IEEE and IEIC of Japan. And recently I am serving as a member of IEEE, MTT, SD, and Diversity and Inclusion Community, and also served as the Vice Chair of IEIC Antenna Propagation Technical Community in Japan. Now, in my research area is mostly focused on electromagnetic wave engineering, wireless communications, and wireless power transfer, and also antenna design. And if you want to know detail, you can use this QR code. Now let me introduce the objective of this research. And here is a typical one-by-one power transfer system. And the total efficiency of this system is the product of four factors. One is eta 1. Eta 1 is the efficiency between the transmitting element and the receiving element. And eta 2 is the efficiencies of matching circuit, both used in receiving transmitting side and receiving side. And eta 3 denotes the efficiency of the rectification circuit, which is usually used at the receiver side and to transform the alternator current to the direct current. And eta 4 means the efficiency of the RF source. So this lecture is only focused on the efficiency of eta 1. It means the efficiency between the transmitting element and the receiving element. As you know, for the wireless power transfer, there are lots of coupling approaches. It can be typically divided into two categories. One is the near-field coupling, also called as no-beam method, and the other is far-field coupling, it's also called as beam method. Two near-field coupling, there are often two methods. One is called as electric field coupling, it's near-field coupling, and the other is the magnetic field coupling. It's usually used like loop or coils. It is also called as induction or something resonance method. So there are two typical near-field couplings. And the two far-field couplings we usually use array antenna to control the beam to transfer the power to the desired target. So it is naturally will be arise the questions: is there an approach to calculate the PTE and the MPTE regardless of the coupling method? The answer is yes, or eMIMO can do it. So this is the object of my lecture. So here, PTE means power transfer efficiency, and MPTE means maximum power transfer efficiency. Let me explain what's eMIMO. eMIMO is a method to calculate PTE and MPTE, and it is based on the electromagnetic relationship between the multiple transmitters and the multiple receivers. It's also called MIMO. And this kind of electromagnetic relationship is exactly expressed as the multiple circuits network parameters, either by S or by Z matrix. Let me introduce the steps of eMIMO to calculate the PTE and MPTE. This is step 1. First we have to calculate the S or Z matrix of the MIMO systems. It can be used by a commercial electromagnetic simulation software or can be measured by using a network analyzer. And this is step 2. From this S matched or Z matched, we can establish generalized Rayleigh quotient for power transfer efficiency. And then so the eigenvalues and eigenvectors of the above generalized Rayleigh quotient. Finally, for step 4, we can obtain the PTE and also the MPTE. Here is a little bit details for step 1 and step 2. Step 1 is from these transmitters and receivers. We can obtain S matrix like this. It can be used by electromagnetic wave simulation software or measured by using a network analyzer. And the step 4 here, we establish the power transfer efficiencies as like this, the Rayleigh quotient. Now, what can eMIMO do? It can, of course, it can calculate PT and MPT regardless of power coupling method, and it can be applicable to near field and far field coupling seamlessly, and it is applicable to any numbers of transmitter and receivers, of course, and it can be used to calculate the optimal excitation of the transmitters and also the optimal load impedance of the receivers for achieving the maximum power transfer efficiency. And further, it also can be used to beamforming for array antenna regardless of the element structure and element space. I would like to show you lots of examples, such as how to calculate an MPT of CISO-WPT, and also for MISO-WPT and MIMO-WPT, and also the example for beamforming. Because the limitation of this presentation, I will skip my slide example very quickly. And here is CISO-WPT systems. Here is the MPT versus the size of the dipole and loop size. And here is the MISO-WPT. And here is the 1 by 1, 4 by 1, 16 by 1, and the maximum efficiencies versus the distance between the receiving antenna and the transmitting antenna can be calculated like this. And also this is a MIMO-WPT system example, and here is the beamforming examples. Conclude my lecture. Here is the features, conditions, applications of eMIMO. It's featured that it can be applied to electromagnetic field, electric field, magnetic field, far field, near field coupling, and also the transmitting mission methods. And it is suitable for any frequency range. and it is applicable to any numbers of transmitters and receivers. And no need to calculate intermediate parameters such as coupling coefficients or Q factor. And it including the mutual coupling between transmitter and receiver elements completely. And the condition to use this method is I have to obtain S matrix or Z matrix. Here is a methodology to obtain S matrix. Four-wave electromagnetic field is very useful, and also measurement using a network analyzer is very useful. And lots of application you can learn from my lecture. It can be used to calculate MTT for CISO, MISO, MIMO systems, and also optimal excitation load impedance both for transmitting and receiving side, and applicable to beamforming techniques. So please enjoy my lecture, where the details of each step of email will be presented, and also lots of application of eMIMO will also be demonstrated. Of course, any questions are welcome, and I'm looking forward to see you soon.